I'm Dr. Jason Brinkley, and this is the chemical equation and reactions. By the end of this video, we will be able to describe the function served by the chemical equation, the basis for chemical calculations, and classify chemical reactions by type, combination, decomposition, or replacement. Now, the chemical equation is a shorthand way of expressing a chemical reaction that obeys the law of conservation of matter. In other words, all of the elements that are present on one side need to be present on the other side. What you start with, you have to end with. Now, the salient points of this is that we use chemical formulas to shorthand our materials, and we put the reactants on the left and products on the right. There's an arrow here to denote that a chemical reaction occurs. On top of that arrow, we can put things like a delta, which tells us that it's been heated up. And we also put states of matter as subscripts to the sides of each of the chemical formulas. Now, as I said, this obeys the law of conservation of matter, so it must be balanced. I've got one calcium on this side, one calcium on this side, one carbon on this side, one carbon on this side. 3 oxygen, 1 and 2 makes 3 oxygen. So it must obey that law of conservation of matter. Now we can classify types of reactions based on some patterns of reactivity. The reaction types we're going to talk about are combination, decomposition, single replacement, and double replacement. Combination reactions are often elements combining to form compounds. They have the general format A plus B goes to AB. Now, the thing is you can't just smash the elements together, okay? You have to get the right formula for the product in order to balance the chemical equation. So, for example, calcium plus chlorine makes calcium chloride, CaCl2. It looks like I just mashed them together, but remember that this forms a 2 plus ion, and this forms a 1 minus ion. So I need 2 of them in my formula for this to be electroneutral. If I take H2 and Cl2 and mash them together, I get HCl. Notice that's HCl, not H2Cl2. That's because this forms a plus 1 and this forms a minus 1. And then I balance it, as we'll talk about in a later video, by putting a 2 in front of the HCl. Similarly, 2H2 plus O2 goes to 2H2O. It's not just smashing them together to make a compound, it's getting the formula right and then balancing. Now, it's not always elements combining to form compounds. For example, magnesium oxide plus carbon dioxide forms magnesium carbonate. Now, decomposition is the opposite of combination. This is AB goes to A plus B. So we already saw the decomposition of calcium carbonate in heat to form calcium oxide and carbon dioxide. Or we can take copper 2 sulfate, pentahydrate, and then decompose that into copper 2 sulfate and water gas. Okay? Decomposition products are the hardest to predict. Single replacement. Single replacement reactions take the format A plus BC goes to AC plus B. This is usually a metal replacing a metal ion in a compound. So for example, if I take this copper 2 sulfate solution and add zinc to it, I make zinc sulfate and copper metal. So the zinc, A here, replaces B to form AC plus B. Similarly, sodium can react with aluminum nitrate to form sodium nitrate and aluminum solid. This is A plus BC goes to AC plus B. Double displacement is where you have Ions swapping partners. AB plus CD goes to AD plus CB. The driving force of this is a formation of a solid or a liquid. So you can see where we form a liquid in water, it's HCl plus NaOH goes to H2O plus NaCl. This is A, B, C, D going to A, D plus CB. Or we can form a solid, barium sulfate, when we react barium chloride aqueous with potassium sulfate aqueous to form potassium chloride and barium sulfate. Now, the thing to remember here is we need to get our formulas right for our products, not just smashing them together. So, for example, it's not K2Cl2, it's KCl, becomes K plus forms a plus 1 ion, chloride forms a minus 1 ion. So let's classify the following reactions as decomposition, combination, single replacement, or double replacement. So here we have one substance going into many substances. So this is a decomposition reaction, decomp. Here we have one substance becoming many substances. So this too is a decomp. Here we have two compounds reacting to form two compounds. Now notice the Na switches with the Ba and the CO3 switches with the Cl to form NaCl3 and BaCO3. So this is a double replacement reaction. And finally, we have two things becoming one. This is a synthesis. Classifying chemical reactions is very important for our understanding of how chemical reactivity occurs. You have plenty of opportunity to classify chemical reactions in your homework and on the questions in the back of the book. And I will see you in the next video.